In the beginning, there is only silence. An ancient, ageless silence that existed long before the first star dared to ignite. It is a silence so complete that even the idea of sound feels impossible. Imagine floating endlessly through this abyss, weightless, untethered, surrounded by a darkness so vast that it dwarfs every fear the human mind has ever held. This is not emptiness. It is a presence. A patient, watchful presence that has been here since the universe's earliest breath, waiting, observing, holding secrets that light has never touched. And as you drift deeper into this cosmic night, a subtle realization begins to form. The darkness itself is not passive. It is alive with meaning. A faint shimmer appears in the distance, not a light, but something even more mysterious. A distortion, a ripple, as though the fabric of space is bending around an object you cannot see. The void is not uniform. It moves with hidden currents, quiet gravitational whispers shaping the destiny of everything that ever was or ever will be. But from your vantage point, suspended in the cosmic gulf, you feel the overwhelming truth settle over you. This darkness is not a backdrop. It is the stage. And we are the uninvited guests stepping into a story far older than our species. The human eye fears darkness because it cannot comprehend what might be hiding inside it. Yet here, in the vast reaches of intergalactic space, that fear transforms into awe, because darkness stretches infinitely in all directions. No stars to guide you. No planets to anchor your sense of place. No warm glow of a sun to promise safety. Only the cold, endless expanse that has swallowed galaxies whole without leaving a trace. The deeper you drift, the more you sense its quiet hum, a kind of cosmic heartbeat pulsing beneath reality itself, subtle yet undeniable. For centuries, humans assumed that darkness was simply the absence of light. A void. A nothingness. But the universe does not waste space. What appears as nothing often holds everything. When astronomers first mapped the heavens, they believed the stars told the entire story. But the more we looked, the more we realized that the stars were merely decorations on the surface of something far grander. The universe is not made of what shines. It is made of what hides. Darkness is not the leftover. It is the foundation. Drifting through this immense shadow, hints of structure begin to emerge. Soft curves of distorted starlight, bending along invisible shapes. Like a sculptor whose hands can never be seen, the darkness molds galaxies, holds them together and guides them in their eternal dance. You watch entire clusters drift past like floating cities swallowed by a fog too thick to pierce. And yet, you know they are not alone. Something surrounds them, an unseen architecture weaving through the cosmos with delicate, immeasurable precision. An uneasy thought arises. If all of this exists outside the reach of light, then what else might be hiding here? Shapes that cast no shadow. Forces that light cannot reveal. Entities or structures born from physics unknown to the world we inhabit. The human mind strains to visualize them, but imagination fails in the face of something so profoundly alien. We evolved to fear the dark corners of forests, caves, and oceans. But this is a darkness on a scale beyond comprehension, a darkness that has existed for billions of years before life crawled from Earth's ancient seas. Far ahead, another distortion ripples through space. It pulls your attention like a silent whisper. The darkness is shifting, wrapping, stretching, recoiling as if responding to some distant stimulus. This is not chaos. It is choreography. A cosmic dance choreographed by forces that neither light nor matter can fully understand. You feel a growing tension, a sense that you are not merely observing the universe, but being observed by it in return. The deeper you travel, the more your perception sharpens. You notice the delicate interplay between what is visible and what is not. Light tries to dominate, tries to reveal, tries to define. Darkness simply waits. It endures. It watches stars burn out and galaxies collide. It watches black holes tear apart entire solar systems. It watches time itself twist and stretch. Through all of this, darkness remains untouched and unbroken. You begin to sense a peculiar rhythm in the void, like a story unfolding in a language you cannot speak but somehow understand. Every faint shimmer, every bending of distant light, every wave of silent gravity feels like a sentence in an ancient cosmic script. The darkness is not random, it is purposeful. It is a boundary between what we know and what we fear to know. And somewhere inside it lies a truth capable of reshaping everything humanity believes about the universe. Then the question rises like a slow tide. If darkness hides more than we ever imagined, what has it chosen not to reveal? What lies behind that shimmering veil that bends reality around it? What intelligence or structure might be concealed within these vast, silent oceans of space? The thought carries a chill deeper than the coldest vacuum. You realize that the greatest mysteries of existence are not found in what glows, but in what refuses to glow. As the final echoes of light fade behind you, you drift fully into the unknown. There is no turning back now. The darkness surrounds you waiting. Not empty, not silent, but full of answers, full of dangers, full of wonders humanity has yet to confront. And in that moment, suspended in an infinite cosmic night, one truth becomes crystal clear. The darkness is not the end of the story. It is the beginning. The first hints arrived quietly, almost shyly, slipping into human awareness long before anyone understood their significance. At observatories scattered across silent mountain peaks, astronomers sat beneath the velvet night, peering through primitive telescopes aimed at a sky they believed they already understood. They expected order, symmetry, predictable motion. Instead they found something unsettling. Galaxies spun too quickly as if gripped by invisible hands. Star clusters moved with a precision that made no sense. The universe, which once seemed like a simple, glowing tapestry, suddenly appeared incomplete. Something was there in the darkness, something massive, something dominant, yet no instrument could detect it. Imagine the moment an astronomer leans back from the eyepiece, confusion spreading across their face. The stars obeyed rules, but those rules no longer matched the math. It was as if the visible universe was only a thin clue, a whisper of the truth. Light had always been humanity's guide, but now light seemed to be lying. The night sky, once a map, had become a mask, hiding a deeper structure beyond comprehension. The mystery deepened with each observation. Galaxies that should have torn themselves apart were somehow held together, their arms stretching gracefully through space like frozen waves. Their rotation was too fast, far too fast to be explained by the mass of the stars alone. Something was missing. Something vast. Yet nothing glowed, nothing reflected, nothing absorbed. It was the first time scientists realized that cosmic darkness was not a void but a powerful presence, shaping everything from the shadows. Picture a scientist pacing alone through a dimly lit observatory corridor, the echo of their footsteps mingling with the quiet hum of distant machinery. The weight of the discovery presses on their mind. If galaxies rely on invisible matter to survive, then the entire universe must be filled with this unseen substance. And if that is true, then everything we believe about the cosmos is incomplete. In that quiet moment, awe and fear intertwine. The universe is speaking, but it is speaking in riddles. The realization spreads quickly across the scientific world. Data from distant galaxies, starlight traveling millions of years to reach Earth, all pointing to the same unsettling conclusion. The visible universe is a mere fragment of the whole. For every star we can see, for every nebula that glows, there is a vast ocean of something else. Something silent, powerful, and hidden. This revelation forces humanity to confront a humbling truth. We are blind, navigating a cosmos built mostly of things we cannot detect. Imagine standing on a cliff overlooking a perfectly still ocean at night. The moonlight touches only the surface, concealing the worlds beneath. That is what scientists faced. The universe's shimmering surface had deceived them for centuries. Beneath the glow of stars lies a deep, unseen structure that determines the shape, motion, and fate of everything. Light, for all its beauty, reveals almost nothing. Astronomers began to question long-held assumptions. What if the universe is not primarily defined by stars and galaxies, but by the invisible forces between them? What if the true architecture of reality is woven from shadows? These questions reshaped cosmology, forcing scientists to look not at what could be seen but at what must be inferred. The cosmos had become a riddle written in darkness. The next breakthrough arrived from an unexpected angle. While studying gravitational lensing, the bending of light by massive objects, astronomers noticed distortions that should not exist. Light from distant galaxies curved around empty regions of space, as if pulled by invisible mountains of mass. The effect was unmistakable. Something immense lurked there, bending light yet remaining invisible. It was the universe's way of whispering, "You are not seeing the full picture." Picture a beam of light traveling across billions of years, passing through regions where no stars shine, yet curving as if distorted by colossal, unseen structures. This single observation shattered any remaining doubts. Darkness was not emptiness. It had weight. It had presence. It shaped the paths of stars, the formation of galaxies, and the distribution of matter across the cosmos. Perhaps it even shaped the fate of the universe itself. This discovery sparked an emotional conflict within the scientific community. On one side was exhilaration. A new frontier had opened, a vast and mysterious realm to explore. On the other was dread. If most of the universe is invisible, how can we ever hope to understand it? How can we map a cosmos built from shadows? How much have we misunderstood? The night sky, once comforting, now felt foreign. The familiar constellations appeared fragile, floating on a sea of the unknown. Scientists developed new instruments, new theories, new models, each revealing a little more of the truth. Yet the deeper they looked, the more unsettling the truth became. Dark matter was not rare. It was everywhere. It filled the spaces between galaxies, wrapped around stars, sculpted cosmic cities, and threaded the universe with structures far larger than anything visible. Every glowing star, every swirling nebula, every grand spiral galaxy was merely a decoration on an invisible framework. Imagine walking through an ancient cathedral at night with only a candle. You see the carvings on the walls but not the pillars holding the structure upright. You admire the stained glass windows but cannot perceive the beams supporting them. That was the position of modern astronomy. For centuries, humanity had admired the decorations of the universe while remaining blind to the massive, dark scaffolding that held everything together. The most jarring realization was this: the universe we see, the stars, planets, galaxies, even ourselves, constitutes less than 5% of what truly exists. 95% of reality is hidden behind a curtain of cosmic darkness. We have been studying the shadows of the true cosmos, not its substance. The universe is not made of light, it is made of what hides from light. As the implications sank in, a new kind of wonder emerged. If darkness shapes the cosmos, then every star is born in the arms of an unseen force. Every galaxy spins to the rhythm of an invisible conductor. Every collision, merger, and structure in the universe is guided by something profoundly mysterious. The cosmic darkness that once evoked fear now inspired reverence. It was no longer a void, it was a revelation. Yet despite all this progress, the central question remained unanswered. What is this invisible matter? What is it made of? How does it interact with reality? The universe seemed to be teasing us, offering clues but withholding answers. And somewhere deep inside that mystery, another thought flickers. The possibility that what we call darkness may not be a passive backdrop but an active, dynamic force shaping the fate of the cosmos. The section ends with a lingering sense of anticipation, as though the universe itself is poised to reveal something far more profound. The first glimpse beyond light has only just begun. The universe reveals its truths slowly, like a storyteller whispering secrets across the ages. But some truths do not arrive with clarity. They come as distortions, anomalies, contradictions, small disruptions that force us to question everything we think we know. That is how the idea of shadowy, unseen matter entered the human imagination. Not with a discovery but with a disturbance. Galaxies refused to behave. Stars at their outer edges moved too quickly, defying the rules of gravity. Something massive was holding them in place, something silent yet powerful, like a ghost with weight. Imagine observing a spinning galaxy from millions of light-years away. The stars near the center swirl in tight circles, glowing like embers in a cosmic furnace. But farther out, where gravity should weaken, the stars keep moving at breakneck speed. They should drift away into the blackness, flung outward by centrifugal force. But they don't. They cling to the galaxy's spiral arms as though bound by invisible chains. That invisible force is the first hint of dark matter, a substance that neither shines nor absorbs light but exerts a gravitational grip stronger than anything we can see. Scientists were stunned. The universe felt like a stage where someone had removed the actors but left their shadows behind. The shadows had mass. The shadows had influence. The shadows bent the motions of stars and shaped the destiny of galaxies. Yet when scientists tried to detect them, nothing responded. No radiation. No reflection. No trace. It was as if the universe had deliberately concealed this substance behind an impenetrable veil. In laboratories and observatories around the world, researchers ran the numbers again and again, but the equations refused to conform. There had to be more mass in the universe than what was visible. Much more. The realization spread like a shockwave through the scientific community. What we call ordinary matter, every atom in every star, every planet, every creature, is just the tip of a cosmic iceberg. Beneath it lies a realm of matter neither visible nor tangible, yet absolutely essential. Without it, galaxies would unravel, stars would disperse, and the universe itself would collapse into chaos. Picture a sculptor shaping clay. Now imagine that the clay is visible but the sculptor's hands are not. You see the form, the curves, the balance, but not the force shaping it. Dark matter is those invisible hands. It molds the structure of the cosmos, guiding the formation of galaxies, clusters and superclusters on scales so vast the human mind can barely grasp them. It is the silent architect of the universe, working tirelessly in the background while light steals the credit. But the deeper scientists looked, the stranger the picture became. Dark matter was not just present in galaxies, it dominated them. For every bit of normal matter in the universe, there was at least 5 times more dark matter surrounding it. The stars we see are like glitter sprinkled on an enormous, unseen structure. The visible universe is merely the decoration, the thin crust of a much deeper reality. As observations improved, a hauntingly beautiful image emerged. Dark matter forms halos around galaxies, vast spheres of invisible mass stretching far beyond the edges of starlight. These halos act like cosmic cages, holding galaxies together with their immense gravitational pull. Without them, spiral arms would fly apart like water droplets spinning off a wheel. Instead, they remain intact, obeying a force that cannot be detected by any conventional means. Imagine floating just outside a galaxy, watching the shimmering stars trace their elegant spirals. Around them, extending tens of thousands of light-years into the darkness, lies a sphere you cannot see but can feel, a gravitational presence wrapping the galaxy like a second skin. It is not smooth. It is lumpy, textured, shaped by ancient collisions and quiet mergers over billions of years. You drift through it without resistance, yet your path bends, pulled by something your eyes cannot perceive. It is unsettling, awe-inspiring, and profoundly mysterious. The more scientists studied dark matter, the more it resembled an enigmatic guardian of the cosmos. It stabilizes galaxies, anchors clusters, and creates the gravitational scaffolding upon which all of cosmic history is written. Yet its true nature remains elusive. It does not emit light. It does not interact with electromagnetic forces. It passes through matter, radiation, and even the densest regions of space without leaving a mark, except for gravity, the only hint of its existence. Every attempt to identify dark matter directly has failed. Massive underground detectors buried deep beneath Earth's surface sit in eternal patience, waiting for a rare interaction that never comes. Particle accelerators push atoms to unimaginable speeds, hoping to forge dark matter in controlled collisions, yet nothing appears. It is as though dark matter exists behind a glass wall, close enough to influence everything, yet forever out of reach. The mystery grows heavier with each unanswered question. What is this shadowy substance made of? Why does it refuse to interact with light? Is it composed of exotic particles unknown to physics, or is it something far stranger, something that defies our fundamental understanding of reality? Could it be a hidden form of matter tied to dimensions we cannot access? Or could it represent an entirely new category of existence? Imagine staring into a vast ocean at night. You hear the waves, you feel their pull, you sense the depth, but you cannot see the creatures moving beneath the surface. Dark matter is that ocean. We live on its surface, illuminated by a thin layer of light, unaware of what lurks below. And somewhere in the cosmic depths, patterns, structures, or even forms of matter beyond imagination may drift silently, shaping the universe from the shadows. The thought stirs both wonder and unease. If something so massive and essential remains invisible, what else might be hidden in the darkness? What unknown forces or entities might inhabit this shadow realm? Could dark matter be more than a substance? Could it be a medium, a domain where new laws, new physics, or even new kinds of life might exist? The section closes with a haunting realization. We do not live in a universe dominated by light, but in one ruled by shadows. And the shadows are only beginning to speak. In the vast darkness between galaxies, where silence stretches farther than imagination can reach, like colossal engines shaping the fate of the universe, hidden not in brilliance but in shadow. These engines do not burn, they do not glow, they do not roar. Instead, they exert power through gravity alone, subtle yet overwhelming, weaving invisible threads that hold the cosmic tapestry together. To understand them, you must drift into the heart of a galaxy cluster, where hundreds of galaxies move through space like luminous ships navigating a sea of shadow. Here, everything feels magnified: gravity, tension, the delicate balance between creation and destruction. The galaxies glide past one another in slow motion, bound by forces no eye can see. Their motions resemble a silent ballet performed on a stage made of darkness. Yet beneath their elegance is immense and relentless pressure, invisible storms of gravitational force pushing and pulling, shaping paths, altering destinies. The darkness between them is not empty, it is thick with dark matter, the unseen engine driving this cosmic choreography. Imagine approaching the edge of a massive cluster, where faint glimmers of distant galaxies flicker like far-off lanterns in an ocean of night. As you drift inward, the gravitational field strengthens, bending the path of starlight itself. The darkness seems to stretch and warp as if wrapping itself around you. You feel the presence of something immense, something that cannot be touched, cannot be illuminated, but can pull entire galaxies into its embrace. This is the heart of the unseen engine, the gravitational core built from dark matter. In the center of these grand clusters, galaxies swarm around each other like bees around a silent queen. They move not because of the mass you see but because of the far greater mass you cannot. Dark matter saturates the cluster's heart in unimaginable quantities, forming a vast, invisible well that everything is falling into slowly over billions of years. It is here that the universe reveals one of its most haunting truths. Light is not in control. What shines is merely decorating what rules. The deeper you descend, the more disorienting the landscape becomes. Instead of stars, you sense gravitational contours, hills, valleys and ridges sculpted from invisible mass. These gravitational landscapes shape how galaxies migrate, how they collide, how they merge and how they evolve. Every swirl, every collision, every quiet drift is choreographed by the dark matter surrounding them. The galaxies themselves are like grains of sand riding a hidden tide. Imagine watching two galaxies drawn toward each other by forces neither can see. Their spiral arms stretch and distort, flinging stars into the void like sparks from a dying fire. Gas clouds collide, ignite and form new stars, while black holes at their centers spiral closer together in a deadly dance. But behind this spectacle lies the true conductor, the dark matter halo enveloping both galaxies, guiding every motion with a silent but irresistible pull. Now picture the entire cluster as a cosmic metropolis, except the city's foundations are invisible. The glowing galaxies are skyscrapers rising from a base you can't perceive. Beneath them, around them, encasing them, are vast reservoirs of dark matter, forming the framework that allows the entire structure to exist. Without this hidden skeleton, the cluster would collapse, disintegrating into isolated galaxies drifting aimlessly through space. Instead, it is unified by invisible mass, bound together by an unseen force older than stars. The more scientists study these clusters, the more they realize how essential dark matter is to the universe's architecture. It is not merely present, it dominates. In a typical cluster, dark matter outweighs normal matter 10 to 1. The stars, planets, and glowing gas that humans have spent centuries admiring make up only a sliver of the whole. The rest is shadow, dense and silent, sculpting everything around it. And yet, as powerful as this dark matter framework is, it remains enigmatic. It does not interact with light. It does not radiate heat. It does not collide with itself or with anything we know. It is the perfect ghost, felt everywhere, seen nowhere. But its influence is undeniable. Its gravity is so strong that it bends light from distant galaxies, warping their shapes into arcs and halos. This gravitational lensing is humanity's only way of mapping the invisible world. Through these distortions, astronomers trace the outlines of dark matter, revealing ghostly structures stretching across millions of light years. Imagine a distant galaxy whose light has been traveling toward Earth for billions of years, only to be bent by a massive cluster along its path. The light curves around an enormous concentration of dark matter, creating a shimmering arc in the sky. That arc is a fingerprint of the invisible engine beneath it, a cosmic signature written across the heavens. To the trained eye, these distortions outline the skeleton of the universe. They expose the hidden framework supporting everything we can see. As the complexity of these structures unfolds, a haunting possibility emerges. Dark matter may be more than a passive substance. It might be dynamic, shifting, responding, influencing cosmic evolution in ways humanity has not yet imagined. Some regions of dark matter appear denser, forming knots that attract galaxies like magnets. Others stretch into vast, unseen filaments connecting clusters like the bridges of an enormous, invisible web. Perhaps these structures hint at a deeper order, patterns sculpted by physical laws yet undiscovered. The silence inside galaxy clusters adds to the unsettling atmosphere. There are no sounds here, no winds, no echoes, only gravitational tension. You float in the dark, watching galaxies drift like phantom ships. Occasionally, two collide, their combined mass sending a ripple through the dark matter surrounding them. These ripples are not waves of sound, but distortions in the gravitational fabric. They travel across the cluster, merging with other disturbances, forming a continuous, silent symphony of motion. Then comes a revelation that unsettles even the most rational mind. Dark matter halos do not merely hold galaxies together, they can collide. But unlike normal matter, dark matter passes through itself with almost no resistance. When two galaxy clusters crash into each other, their glowing gas collides, heats up, and slows down. But their dark matter have simply glide through, indifferent, unaffected. It is as though two ghosts collided but continued drifting, unaware of the impact. This eerie phenomenon, observed in the famous bullet cluster, offers one of the strongest pieces of evidence that dark matter is real. But it also deepens the mystery. How can something so massive be so untouchable? As you drift deeper into the cluster's core, the contrast between chaos and order intensifies. You witness galaxies being shredded by tidal forces, stars flung into deep space, gas clouds compressed into star-forming nurseries. Yet through it all, the dark matter halo remains calm, steady, unbreakable. It is the quiet anchor around which all visible chaos swirls. It guides destruction and creation with the same indifferent hand, shaping the universe with a patience far beyond human comprehension. The deeper the mystery grows, the more the mind wonders. Is dark matter simply a substance we have not yet understood, or is it something more profound? A different kind of existence, operating on principles unknown to our physics? Could it be an echo of the early universe, a relic of dimensions beyond our perception, or something entirely outside the framework of matter as we know it? As the section closes, the image lingers, a galaxy cluster floating in an ocean of darkness, glowing like a fragile constellation of islands surrounded by a vast, unseen continent. The engines of the universe hum softly in the shadows, guiding the cosmic story with invisible hands, waiting for the day humanity finally learns to see what has always been there. Far from the glowing cities of stars and the crowded highways of galaxy clusters, there exist regions of the universe so vast, so empty, and so eerily silent that they defy all instinct. These are the cosmic voids, expanses spanning hundreds of millions of light-years, where galaxies are rare and darkness reigns with an almost sentient stillness. Entering a void feels like stepping into a world where the universe has paused, where creation has withdrawn, leaving behind a silence so profound it presses against the mind. Yet these immense dark regions are not abandoned. They may be hiding processes, forces, and mysteries even more ancient and more elusive than the ones found in the brightest corners of space. As you drift across the threshold of a void, the last few distant galaxies shrink into faint sparks behind you. The emptiness around you grows overwhelming. It feels bottomless, a darkness with no texture, no motion, no echo. But the longer you remain, the more you begin to perceive a faint structure beneath the stillness. The void is not dead. It is breathing, expanding, shaping, and responding in ways subtle enough to escape the earliest astronomers. What seems empty is actually dynamic, governed by forces we barely grasp. Imagine floating through a sphere of space so immense that the entire Milky Way would be a mere flicker inside it, and yet, throughout its vastness, you might find only a handful of lonely galaxies. They drift like forgotten lanterns in a black ocean, isolated from the gravitational pull of their larger cosmic neighbors. These galaxies evolve differently, unbound by the pressures of dense environments, like solitary islands untouched by continental storms. Their stars form more slowly. Their structures twist into unusual shapes. They are survivors of a cosmic wilderness, shaped by the profound emptiness surrounding them. The voids themselves act like pressure zones in the cosmic web. As dark matter and normal matter collapse into dense filaments and clusters, the voids expand outward, becoming larger and emptier over time. Their growth pushes galaxies and dark matter into more structured regions, contributing to the formation of the universe's grand architecture. In this way, emptiness is not passive, it actively sculpts the cosmos. The voids are the quiet architects shaping everything from behind the scenes. But the most haunting element of these voids is not their scale or their emptiness. It is their silence. Here there are no swirling nebulae glowing with the birth of stars. No crowded regions buzzing with supernovae or galactic collisions. No gravitational battles waged between clusters. The voids offer only quiet, unending darkness, broken occasionally by the faint glimmer of a distant galaxy struggling to survive alone. You feel suspended in a place where time moves differently, where the universe's heartbeat grows faint. Yet this silence is deceptive. The voids harbor mysteries that challenge the foundations of physics. Some researchers have noticed that the few galaxies found inside voids sometimes behave unpredictably. Their motion through space does not always match the pull of nearby structures. Their shapes often defy the patterns seen elsewhere. It is as though they are responding to forces we cannot see, drifting along paths that seem to originate in the depths of darkness itself. Imagine one such galaxy, a tiny dwarf system drifting through a void unmoored from the cosmic web. Its stars flicker with a fragile glow, like embers left behind after a fire. Around it, dark matter should be sparse, yet gravitational measurements tell a different story. There is mass present where there should be none, a presence that defies the logic of cosmic evolution. Some void galaxies seem to carry with them a reservoir of dark matter far richer than expected, as though they have encountered something hidden within the emptiness, something that has clung to them like a shadow. This has led some scientists to propose theories that border on the unsettling. One idea suggests that within the deepest regions of voids, unknown forms of dark matter or exotic fields may accumulate, immune to detection but capable of influencing galaxies that wander through them. Another proposes that voids might be windows into regions where the laws of physics operate differently, places where cosmic expansion stretches spacetime in unusual ways. And then there are more speculative ideas, that voids could contain structures or phenomena entirely unconnected to the world we know, hidden not because they are small or faint, but because they are fundamentally different. Imagine drifting deeper into the heart of a void, where even the faint starlight from distant galaxies dwindles into nothingness. There is no reference point now, no anchor, no direction. The darkness seems thicker, as though infused with a presence rather than an absence. In this profound emptiness your senses sharpen. You begin to perceive faint ripples in the gravitational field, tiny irregularities, subtle distortions, as though something unseen is moving or shifting in the dark. You reach out with your perception and feel the shape of a vast emptiness that is not uniform. There are gradients, pockets, fluctuations like currents in a deep ocean. Perhaps this is where the universe keeps its oldest secrets. Perhaps the voids are the quiet chambers of creation, untouched by the violence of star birth and death. Or perhaps they are the hiding places of something the cosmos is not yet ready to reveal. The atmosphere becomes heavier, not with sound but with anticipation. Every step deeper into the void feels like a step closer to a boundary, a threshold between the known universe and something beyond comprehension. The idea forms slowly. What if the voids are not empty because matter fled them, but because something else claimed them long before galaxies existed? What if these enormous cosmic hollows are not just regions of low density, but domains reserved for forces or structures we have yet to imagine? The more you consider this possibility, the more the void shifts from a place of emptiness to a place of hidden significance. Darkness, once feared for its lack of light, begins to appear as a cradle for deeper truths. And as you drift through this infinite stillness, one haunting question echoes through the abyss. Are these cosmic voids truly empty, or are they concealing something the universe has carefully kept out of sight? The silence offers no answer. Only the darkness listens. In the quiet depths of the cosmos, where stars drift like solitary sparks and galaxies glide on invisible rails, something stirs with a subtle but undeniable motion. It is not light, nor gas, nor dust. It is darkness itself, moving, flowing, shifting through the universe with the grace of a silent river. Unlike the chaos of colliding galaxies or the violence of supernovae, this motion is soft, patient, almost purposeful. It is the motion of dark matter, the unseen tide that shapes the cosmic landscape without ever revealing its form. Imagine drifting just outside a galaxy, watching its stars orbit like dancers in an endless waltz. Beneath them, around them, and beyond them, an invisible current flows. At first, it is impossible to detect. There is no glow, no spark, no flicker to betray it. But then, a subtle shift appears in the paths of distant stars. A slight bend. A gentle acceleration. A motion that cannot be explained by anything visible. This is the current of dark matter, silent waves of unseen mass gliding through space, dictating the choreography of the cosmos. The idea that darkness moves is unsettling, because motion implies purpose, and purpose implies something more than mere existence. But dark matter does not drift randomly. It follows patterns, swirling in halos around galaxies, streaming between clusters, flowing along vast filaments of the cosmic web. These flows are not chaotic. They are structured, synchronized in ways that suggest a deeper order. It is as though the universe breathes through these rivers of shadow, exhaling gravity and inhaling silence. Scientists detect this movement not by seeing dark matter itself but by watching how it pulls, nudges, and guides the stars. Galaxies fall into its streams, drawn toward dense concentrations like leaves carried along a river's current. Some regions are calm lakes of dark matter, steady and smooth. Others are turbulent rapids where invisible mass collides, compresses, and stretches spacetime. Mapping these currents is like trying to understand the wind by watching the motion of drifting seeds. Every shift, every tilt in the starlight reveals the unseen forces sweeping through the void. Imagine watching a galaxy drift across millions of years, its path gently curved by something no instrument can detect. It moves as though navigating a riverbank carved from shadow. These motions are not merely gravitational effects. They are signatures, traces of dark matter streaming, pooling, and interacting in ways we struggle to comprehend. And yet, the deeper astronomers look, the stranger the patterns become. Some galaxies rotate faster than they should. Others move sideways, almost drifting against the expected flow. Entire groups of galaxies appear to be sliding along invisible highways carved into the cosmos. These motions cannot be explained by visible mass alone. Something in the dark is pushing them, pulling them, guiding them across unimaginable distances. In the most remote stretches of intergalactic space, dark matter flows like a whispering wind. It carries subtle ripples, disturbances that move across its vast structure. These ripples pass through galaxies as though they are not there, bending their paths without ever touching them. It is a force without contact, a presence without form. To modern physics, this is both fascinating and deeply frustrating. A phenomenon that shapes everything yet reveals almost nothing. Imagine drifting within one of these invisible streams. There is no sensation of movement, no pressure, no resistance. But you can feel the gentle tidal pull on the stars around you. You watch entire clusters shift as though following a current only they can sense. It is a strange, dreamlike experience, floating on a river that has no water, no sound, no light, yet carries the weight of thousands of galaxies. The mystery deepens when scientists observe unexpected fluctuations, surges and voids within dark matter that have no clear cause. These waves ripple across the cosmic web, altering the motion of galaxies with a rhythm that hints at something more than random noise. It is as though dark matter is responding to something, perhaps to itself, perhaps to forces still unknown. Could these fluctuations be echoes of ancient cosmic events, remnants of interactions at the universe's beginning? Or could they be evidence of a deeper structure within the darkness, patterns that suggest complexity? Some researchers speculate that dark matter might not be completely passive. Perhaps it interacts in ways we have not yet discovered. Perhaps it clumps, fragments, or forms temporary structures that shift over time. Or perhaps its motion is governed by something beyond our three-dimensional understanding, an influence bleeding in from higher dimensions or a different layer of physical reality. Imagine for a moment that dark matter is not merely drifting but communicating, transmitting information through gravitational waves, responding to events across billions of light years. Though this may sound like science fiction, the universe has revealed stranger truths. What was once thought impossible often becomes the foundation of new physics. In certain regions, dark matter flows with extraordinary precision, sculpting gravitational channels that guide the movement of entire galaxy groups. These channels resemble invisible highways threading through the cosmos, and galaxies follow them with uncanny obedience. In other regions, dark matter swirls into vast, circular eddies, like whirlpools, where galaxies cluster tightly, forming dense cosmic hubs. The question grows louder: does dark matter simply obey gravity, or does it obey rules we have not yet discovered? Could its flows be influenced by unknown particles, exotic fields, or even forces that predate the Big Bang? The idea is intoxicating and terrifying. As you drift deeper into a stream of dark matter, you sense the tension between what is known and what remains hidden. The darkness is in motion, shaping reality with each silent wave. And while scientists search for answers, the only thing that becomes clearer is how little we truly understand. The section closes with a lingering unease. If the darkness moves with such purpose, then what is guiding its motion? And what deeper truths lie hidden within its silent currents? There comes a moment in the history of science when the universe reveals not just a secret, but a rebellion. A defiance so profound that it overturns everything humanity thought it understood about the cosmos. That moment arrived when astronomers realized the expansion of the universe was not slowing down as logic dictated, but speeding up. Galaxies were not simply drifting apart, they were accelerating away from each other as though pushed by an unseen force. It was as if the fabric of space itself had chosen to revolt, to tear free from gravity's grip, to expand with increasing hunger. This force became known as dark energy, but the name says nothing of its true nature. It is not merely dark. It is dominant, relentless, and deeply mysterious. Imagine floating between galaxies, suspended in a region where spacetime stretches like a living membrane pulled taut. At first, the motion is subtle, so gentle you barely notice it. But as you remain still, you begin to feel the universe expanding beneath you. Space grows not around galaxies but between them. Every second, every minute, every hour, the void widens. The galaxies drift apart faster than before, as though the universe itself is inhaling deeply, expanding with a silent determination. With each moment that passes, the expansion accelerates, an invisible pressure pushing against everything, refusing to let the cosmos rest. It is a force without origin, without direction, without any known particle to carry it. And yet, it accounts for nearly 70% of everything in existence. A presence so vast, so overwhelming, that it shapes the fate of the universe more strongly than gravity, more strongly than dark matter, more strongly than the light we see. Dark energy is not confined to one region. It permeates all of space, filling the cosmos like an invisible fog. But unlike fog, it does not gather or drift. It remains uniform, steady, persistent, a quiet but unstoppable pressure that stretches reality itself. Imagine watching the distance between two galaxies grow, not because they move, but because space grows between them. The galaxies are pinned like insects on a stretching canvas, helpless against a force they cannot resist. For scientists, this realization was as shocking as waking up to find the laws of physics rewritten. According to every expectation, gravity should slow the expansion of the universe. Yet data from distant supernovae revealed something strange. The light reaching Earth was dimmer than it should have been, stretched by a universe expanding faster than predicted. It was the cosmic equivalent of hearing footsteps speeding away in the dark, even though nothing visible was running. The emotional impact of this discovery cannot be overstated. For centuries, humanity believed the universe was a stable entity, governed by predictable laws. Now, that stability seemed to be slipping away. The cosmos was not slowing, it was accelerating, propelled by an unknown force with no identifiable source. It was as though the universe possessed a hidden engine, one that did not rely on matter, light, or energy as we know them. Imagine standing at the edge of the observable universe, where the last traces of starlight flicker like dying embers. Beyond this horizon lies a region expanding so quickly that even light cannot cross it. Galaxies disappear over this boundary, not by motion but by the stretching of space, vanishing from the visible cosmos forever. This is the effect of dark energy. It pushes so hard that parts of the universe are slipping away into unreachable darkness. Some scientists describe dark energy as a form of negative pressure, a tension within spacetime that drives it to expand rather than contract. Others propose that it might be a property of the vacuum itself, an eternal surge of quantum fluctuations giving rise to a force that never diminishes. More adventurous theories imagine dark energy as a field, dynamic and evolving, perhaps interacting with matter in ways too subtle to detect. And then there are those who wonder if dark energy hints at something far stranger, an influence from outside our universe or a symptom of higher dimensional physics bleeding into our reality. Imagine stretching a rubber sheet. At first, the force required to pull it grows with tension. But now imagine that the sheet itself begins stretching on its own, without effort, expanding faster and faster until the edges race away from each other. This is the universe under the influence of dark energy. The more space expands, the more dark energy fills it. The more dark energy there is, the faster space expands. A runaway process, a cosmic feedback loop with no clear beginning or end. The consequences would be profound. Galaxies will drift apart until their light can no longer reach one another. Stars will fade in isolation. The night sky will grow emptier, darker, lonelier. Future civilizations might look into the cosmos and see nothing beyond their own galaxy, unaware of the grand cosmic network that once surrounded them. Dark energy is not merely reshaping the universe, it is erasing its past, spreading galaxies so far apart that they vanish beyond the limits of perception. But the true fear lies not in the distant future. It lies in the possibility that dark energy might change. If dark energy grows stronger over time, the universe could face a catastrophic fate known as the Big Rip. In this scenario, the accelerating expansion becomes so extreme that it tears galaxies apart. Then solar systems. Then planets. Eventually, even atoms themselves would be ripped from existence as space stretches infinitely fast. It would be the universe's final rebellion, the destruction of everything, driven by the very force that once allowed it to expand. On the other hand, dark energy might weaken. It might fluctuate. Might transform. The universe might slow again or collapse inward, reversing into a gravitational implosion known as the Big Crunch. Or perhaps dark energy will trigger an entirely new event, one that births another universe, a new cycle of cosmic rebirth hidden within the death of the old. As you drift deeper into the vastness, you realize the unsettling truth. Dark energy is not simply a force. It is a question. One that the universe whispers but never answers fully. Why does space expand? Why does it accelerate? What lies beneath the fabric of reality that gives rise to such a profound influence? The cosmic rebellion continues, silent and unstoppable. Galaxies accelerate. The void expands. The universe grows colder, darker, more fragmented. And yet, somewhere within this unstoppable expansion, there remains a sliver of hope. A sense that understanding dark energy might unlock a deeper truth about the cosmos, about existence, about the structure of reality itself. In the end, as you watch the galaxies drift away like fading lanterns, you feel the weight of the mystery pressing in from all sides. Dark energy is not simply pushing the universe apart. It is pushing humanity toward the edge of understanding, toward a frontier where physics becomes philosophy, and where every unanswered question echoes into the accelerating night. To stand at the edge of the observable universe is to confront a boundary unlike any other, a frontier not of matter but of perception. It is the place where light becomes memory, where time stretches thin, and where reality begins to blur into the impossible. Here, the last photons that left distant galaxies billions of years ago reach us as faint, trembling whispers. Beyond them lies a darkness untouched by even the fastest beams of light, a realm sealed not by walls, but by the relentless expansion of space itself. To reach this boundary is to witness the limit of what humanity can ever see. Imagine drifting toward this cosmic horizon. At first, it feels no different from the familiar deep space between galaxies. Stars remain distant glimmers, and nebulae glow faintly like ancient lanterns. But slowly, subtly, something changes. Light from distant objects begins to stretch, its wavelengths elongating into colder hues. The farther the source, the more distorted its color becomes, until once bright galaxies appear as faint smudges of infrared glow. You are not moving faster, space itself is stretching beneath you. The universe is pulling its secrets away, one fraction of a wavelength at a time. This boundary is known not by a physical marker, but by a simple truth: beyond it, light cannot keep up. The expansion of the universe outpaces its speed, trapping entire regions in a darkness from which no information can escape. Galaxies exist out there, vast, beautiful, full of stars and worlds, but they are lost to us forever, slipping beyond the cosmic shore like ships disappearing over an endless horizon. Their light will never reach Earth. Their histories will never be known. They remain ghosts of the universe's distant youth. To gaze into this boundary is to look backward in time. Every point of light you see is not a present event, but an ancient one. A galaxy shining near the cosmic edge appears as it was billions of years ago, long before Earth even existed, long before the first atoms of your body formed in the heart of a dying star. You witness epochs so ancient that even imagination struggles to comprehend them. You see the universe not as it is but as it was, a record of its childhood etched into the fabric of spacetime. As you drift closer to the horizon, the silence deepens. Not because sound cannot travel in space, it never could, but because the darkness here feels heavier, more intentional. Light grows weaker, stretched to the point where it becomes nearly invisible. Photons that have traveled for billions of years dissolve into the background, fading into wavelengths too long for any eye to witness. It is as though the universe is whispering its last visible secrets before drawing a curtain over the rest. Scientists call this limit the cosmic light horizon, yet the name fails to capture the haunting beauty of the boundary itself. It is not just the edge of what we have seen, it is the edge of what we can ever see. No matter how advanced our telescopes become, no matter what technologies future civilizations invent, this boundary will always retreat ahead of them. The accelerated expansion of space ensures that the horizon grows more unreachable with every passing moment, like a mirage drifting away as you walk toward it. Imagine reaching out toward that boundary, watching distant galaxies flicker like dying embers before vanishing into total darkness. You are witnessing the universe erase parts of itself from view. One by one, galaxies slip beyond the horizon, swallowed by the accelerating expansion. Their light stops reaching us. Their stories end abruptly not because they die, but because they are carried away faster than light can chase. It is a cosmic tragedy played out in perfect silence. And yet, the mystery does not end with disappearance. Some scientists believe that beyond the horizon lies a region still governed by the same physics we know: galaxies forming, stars burning, planets orbiting. Others suspect that these unreachable zones may be vastly different, shaped by conditions we cannot measure or even imagine. Could variations in cosmic density beyond the horizon affect our own universe? Could gravitational forces from beyond the visible region be subtly tugging at what we see, influencing motions we cannot explain? Or is the horizon a hard boundary, a true separation between our universe and something else entirely? Imagine drifting closer, feeling time stretch around you. The horizon does not come nearer. Instead, the universe behind you appears to recede. You begin to sense an odd tension, like a threshold between knowledge and eternal mystery. What lies beyond? More galaxies? More dark matter? Or something stranger? Regions where the laws of physics differ, where constants change, where reality itself bends into forms we cannot grasp. As the expansion accelerates, the horizon becomes not only a limit of sight, but a limit of influence. Beyond it, distant galaxies no longer affect us gravitationally. They are cut loose, isolated in their own expanding pockets of space. The universe fractures into countless island realms, each drifting away from the others with increasing speed. The cosmic web itself becomes stretched, strained, and ultimately divided. In this fragmented future, observers in distant galaxies will see only themselves, unaware that countless other galaxies once shared their sky. Standing metaphorically at this boundary forces a sobering realization. The universe is not eternal in its visibility. There will come a time when even the nearest large galaxies fade from view. The cosmos will grow darker, emptier, colder. The night sky of future civilizations may be almost blank, a handful of faint stars surrounded by endless black. The history of the universe will become hidden, inaccessible, erased by the unstoppable expansion driven by dark energy. Yet in this growing darkness, there is also a sense of wonder. The edge of the observable universe is not merely an end, it is an invitation. A reminder that reality is larger, deeper, and stranger than anything we can perceive. Beyond the cosmic horizon lies the unseen majority of the universe, a realm of infinite possibility. As you linger on this boundary, watching the last traces of ancient starlight fade, one truth becomes clear. The universe is far bigger than our senses allow, and the greatest mysteries lie not in what we see, but in what remains forever beyond the reach of light. There are moments when the universe reveals a pattern so vast, so intricate, that it feels less like a physical structure and more like the blueprint of existence itself. This is the cosmic web, the hidden architecture of dark matter stretching across billions of light-years. To see it is to witness the skeleton of the universe, a vast network of invisible filaments connecting galaxies like beads on an endless thread. But this web is not just a structure. It is a map of power, a silent realm where darkness shapes the destiny of everything that glows. Imagine rising high above the universe, far beyond the Milky Way, far beyond the clusters of galaxies, until they blur into a faint mist of light. From this impossible vantage point, the cosmos reveals its true form. Not a random scattering of stars, but a web, vast and shimmering though not with light. Its filaments glow only in gravitational influence, only in the way they bend space and command matter. The threads stretch from one corner of the universe to another, forming a colossal lattice where galaxies are mere nodes in an unimaginable network. As you drift closer, the structure becomes clearer. Each filament is a river of dark matter, dense, cold, and invisible, flowing through the cosmos. Galaxies cling to these invisible rivers like drifting boats caught in a current. They form where the filaments intersect, gathering in great clusters at nodes where the gravitational pull is strongest. These nodes become cosmic cities, bustling with trillions of stars, while the filaments act as highways between them. Everything we see, every glowing point in the night sky, exists because of this hidden web beneath it. Yet the filaments themselves, though invisible, are teeming with complexity. Their shapes twist and stretch across space, weaving patterns as ancient as the universe. Some are thin and delicate, faint threads connecting distant clusters. Others are thick and powerful, pulsing with dark matter dense enough to shape the movement of entire superclusters. These filaments are alive with motion, not in the biological sense but in the way a river is alive, constantly shifting, evolving, reshaping the land around it. The galaxies within them are not merely passengers. They are shaped by the filaments, stretched into elongated forms, flattened by tidal forces, or fed streams of gas and dark matter that trigger bursts of star formation. Even their rotations are influenced by the gentle pull of these dark rivers. If you watch a galaxy forming along a filament, you will see how the invisible scaffolding determines its future. Its shape, its spin, its mass, its very ability to survive. Imagine drifting along one of these cosmic filaments. There is no light to guide you, only the faint distortion of background galaxies bending around the dark matter beneath. Gravity becomes your compass. You feel its pull like a soft current, drawing you deeper along the thread. Sometimes the pull grows stronger, signaling a node ahead, a gathering place where filaments converge. Other times the current weakens, guiding you toward the vast, empty voids that lie between the strands. You are navigating a universe made not of light but of gravity. The deeper you dive, the more haunting the beauty becomes. The cosmic web resembles a neural network, a vast cosmic brain where each node communicates with others through gravitational signals. Some scientists have even suggested that the universe may behave like a giant information processing system, with dark matter filaments acting as conduits of cosmic interaction. It is a metaphor perhaps, but one that feels eerily fitting. The structure of the universe mirrors the structure of thought. The architecture of galaxies echoes the architecture of consciousness. This resemblance leads to a tantalizing question. Could patterns within the dark matter web represent more than mere physics? Could they hint at a deeper form of organization, one not random but purposeful? Though science does not support the idea of cosmic consciousness, the parallels ignite wonder. The web seems almost intelligent in the way it distributes matter, organizes galaxies, and shapes cosmic evolution. It is the closest thing the universe has to a central nervous system. Yet the filaments are not static. They sway, stretch, and shift over billions of years. They grow thicker as galaxies fall into them, feeding the clusters at their intersections. They thin as dark matter drains into dense regions. Over unimaginable time spans, the web reshapes itself like a living organism adjusting to new conditions. It is a dance slower than any biological process, yet governed by principles just as intricate. Within some filaments, strange structures appear, dense knots of dark matter unaccompanied by any visible galaxy. These are called dark halos, gravitational islands with no luminous counterpart. They raise unsettling possibilities. Could galaxies exist that we cannot see at all? Could there be vast, dark ecosystems of matter moving through these filaments, invisible to every instrument we possess? If stars are rare decorations on the web, what lies hidden in the parts that never glow? Imagine drifting near one of these dark halos. To your eyes, it is nothing, a region of blackness indistinguishable from the void. But your trajectory bends sharply as you approach, pulled by a mass you cannot observe. You feel the gravitational well, deep and consuming, yet find no visible structure within it. It is like encountering a massive creature in the depths of the ocean, one that leaves no sound, no shadow, no wake, only the force of its presence. The existence of these dark halos suggests that the cosmic web may contain forms of matter or structure more exotic than galaxies themselves. Some theories propose self-interacting dark matter, capable of forming its own kinds of clumps and flows. Others imagine hidden particles gathering in ways that mimic galaxies without producing light. And the most daring ideas suggest that the web may host entire realms of invisible phenomena, structures as rich and varied as the luminous universe, but forever beyond human sight. As you drift deeper into the web's intricate lattice, you sense how profoundly it shapes the cosmos. It is not simply a backdrop, but the very framework on which everything hangs. Without the web, galaxies would scatter randomly. Without the filaments, clusters would never form. Without the nodes, the universe would be a loose cloud of drifting stars. Dark matter is the architect. The web is its masterpiece. And yet, for all its influence, the web remains silent, hidden, and unknowable. You cannot see it directly. You cannot touch it. You cannot illuminate it. But you can feel its presence in the path of every star, the curve of every galaxy, the shape of every cluster. It is the unseen structure shaping the universe's fate. In the first moments after the birth of the universe, before stars flared into existence and before atoms learned to bind themselves together, darkness ruled with ancient authority. It was not the darkness we know now, not the quiet, cold emptiness between galaxies, but a primal darkness filled with raw potential. The universe was a seething ocean of energy, thick with particles that flickered into existence and vanished again within fractions of a second. In this chaotic storm, long before light found its voice, something else formed first: dark matter. Ancient, silent, and indifferent, it emerged as the earliest sculptor of cosmic destiny. Imagine drifting backward through time, past the formation of galaxies, past the birth of the first stars, past even the moment when atoms first cooled enough to cling together. The universe grows hotter, denser, more violent. Space itself trembles with energy. Particles crash into one another with unimaginable force. The air, if one could call it that, is filled with flashes of interaction, sparks of creation and destruction. Yet in this primal chaos, dark matter acts differently. It does not collide. It does not glow. It passes through the turmoil untouched, like a shadow immune to fire. As the universe expands, the storm begins to calm. Light particles scatter violently, unable to travel far before smashing into others. Normal matter remains trapped, unable to move freely. But dark matter flows unhindered, slipping through the crowd of energetic particles with silent grace. It begins to gather in clumps, tiny seeds of gravity that will one day become the hearts of galaxies. These early structures form long before any atom exists to fall into them. The universe is still opaque, still glowing with the heat of creation, yet dark matter is already weaving the first threads of the cosmic tapestry. Imagine watching these invisible seeds grow. They swell into dense regions of gravitational potential, pulling in surrounding dark matter to form ever larger halos. These halos do not shine, but their influence is immense. They create valleys in the gravitational landscape of the young universe, deep wells into which matter will eventually fall. The entire future of the cosmos is being sculpted here, in these first few minutes and hours, long before light gains the clarity to illuminate anything at all. As time continues its relentless march forward, the universe cools. The thick haze begins to fade. After nearly 380,000 years, the glow of the Big Bang finally fades enough for light to move freely. The universe becomes transparent. For the first time, the cosmic microwave background shines across space, revealing a faint pattern, tiny ripples in temperature. These ripples are the fingerprints of the early universe, but hidden beneath them are deeper, more ancient truths, the distribution of dark matter, laid down long before atoms existed. Imagine standing within that ancient fog as light breaks free, watching the universe transition from opaque fire to transparent emptiness. Behind the shimmering veil, you glimpse the dark matter scaffold already in place, vast invisible structures stretching in every direction. These are the primal skeletons, the earliest frameworks on which galaxies will be built. Without them, the universe would remain a diffuse soup of gas, unable to form anything meaningful. Dark matter guides the arrangement of matter with patience older than time, shaping everything long before it is seen. As the gas begins to cool, it falls into the gravitational wells left by dark matter. Clouds collapse, spinning and heating until the first stars ignite. These stars burn with blue-white fury, massive and short-lived, illuminating regions that have never known light. Galaxies swirl into existence, their shapes carved by the dark matter halos that cradle them. Clusters form where multiple halos merge, creating vast cosmic cities. Superclusters stretch across unimaginable distances, filling the universe with structure and symmetry. Yet through it all, dark matter remains unseen. It does not react, it does not shine, it does not age. It simply persists, guiding each step of cosmic evolution with quiet authority. It is the timeless architect, older than atoms, older than stars, older than the galaxies it shepherds. Imagine now a moment even earlier, before dark matter fully settled, before its structure solidified into the seeds of the cosmic web. Some theories suggest that dark matter formed not at the same time as normal matter, but in an even earlier event, perhaps during a phase transition in the universe's first trillionth of a second. In this view, dark matter is not just ancient. It is primordial in a way that defies comprehension. It may be composed of particles forged in conditions never again repeated, conditions too extreme for ordinary matter to survive. This possibility raises haunting questions. If dark matter predates the universe's familiar physics, could it carry imprints from a time before our universe expanded? Could it hold echoes of earlier cosmic cycles, memories of dimensions or states of reality that no longer exist? It is a thought that blurs the line between physics and philosophy. If dark matter is older than the Big Bang's visible remnants, then it may be the oldest witness in existence, a silent recorder of events no human theory has yet dared to describe. As you drift through the ancient universe, watching the first structures form in darkness, you feel a pull, an awareness that everything familiar, everything bright, everything alive, rests upon a foundation carved by forces older than stars. In every direction, dark matter flows into the shapes that will define billions of years of cosmic history. It is preparing the universe for light, carving the channels through which radiation will travel, molding the future long before the first spark of life emerges. Even now, billions of years later, the influence of this primordial darkness remains. Galaxies still orbit the gravitational wells formed in the universe's infancy. Clusters still align along filaments shaped by early fluctuations. The cosmic web, which seems so vast and complex today, is a direct descendant of those first invisible seeds. There is a point in the journey of understanding when the universe stops feeling like a solved puzzle and begins to resemble a vast, unfinished equation. It is the moment scientists realize that the physics they have trusted for centuries, the laws that describe falling apples, orbiting planets, and the birth of stars, can no longer explain the behavior of the cosmos. Something is missing. Something essential. And this missing piece, this silent gap in our knowledge, casts a shadow over everything we think we know. The universe is functioning with rules we have not yet discovered, and the missing physics weighs heavily on every observation, every experiment, every unanswered question. Imagine a scientist standing before a chalkboard filled with equations. Every symbol is familiar. Every line of logic follows known laws. Yet the moment they try to calculate the motion of galaxies, the expansion of space, or the distribution of dark matter, the numbers collapse into contradictions. It is as though the universe has written its story in a language only half translated. Gravity should behave one way but it behaves another. Matter should appear where predicted, but it doesn't. Forces should align neatly, yet they resist understanding. The chalkboard becomes a battlefield between human logic and cosmic truth. The most unsettling realization is not that we are wrong, but that we are incomplete. The physics we use to describe the universe is astonishingly successful at small scales, atoms, molecules, planets, even stars. But at the grandest scales, it begins to crumble. Galaxies rotate too fast. Clusters move in ways no equation predicts. Space expands in defiance of gravity. There is a cosmic whisper suggesting that the laws we hold sacred are only fragments of a greater framework. Imagine drifting through a galaxy cluster, watching the swirling dance of hundreds of galaxies. Gravity should dictate their motion with precision. Yet something is off. They orbit too quickly, as though propelled by an invisible force or held by an unseen mass. It is not a small discrepancy, it is enormous. To make the equations match what we observe, scientists must add vast amounts of unseen matter. But adding dark matter only deepens the mystery, because the nature of this matter remains utterly unknown. Normal physics cannot explain it. No particle in the standard model fits its behavior. No force in known physics interacts with it. Dark matter sits outside every theory, an intruder that refuses classification. And so the equations break. The models fail. Humanity is left staring at a universe that behaves as if guided by laws we haven't yet discovered. The same crisis appears with dark energy. Einstein's equations predicted that gravity should slow the expansion of the universe. Instead, the expansion accelerates. The math rebels. To reconcile theory with observation, scientists must invent a new form of energy, one that fills all of space, one that pushes everything apart. But what is this energy? Where does it come from? Why does it exist? Physics offers no answer. It is as though the universe has introduced a new rule without explanation, leaving scientists scrambling to rewrite their textbooks. Imagine looking at the cosmic microwave background, the faint afterglow of the Big Bang, mapped in exquisite detail. Tiny variations in temperature reveal the universe's early structure. But when physicists run simulations using known physics, the resulting universe looks wrong. The patterns don't match. The structures don't form correctly. Something is missing from the equations. Some hidden ingredient shaped the early universe, leaving fingerprints we can detect but cannot identify. Even gravity, the oldest known force, is now under suspicion. Einstein's theory describes it beautifully at human scales and stellar scales. But at cosmic scales, something breaks. Perhaps gravity behaves differently than we expect. Perhaps it weakens or strengthens under certain conditions. Perhaps it interacts with dark matter or dark energy in ways we cannot see. Or perhaps gravity is not a force at all, but an emergent phenomenon, a shadow of deeper physics hidden beneath the surface of reality. Imagine drifting through the cosmic web, watching filaments of dark matter stretch across billions of light years. These structures formed far too quickly for normal physics to explain. They align too neatly. They span too far. The equations governing the early universe struggle to predict their formation without invoking unknown laws. It is as though the universe arranged itself with knowledge of rules we have yet to uncover. The missing physics haunts laboratories on Earth as well. Deep underground, detectors the size of buildings wait for a single particle of dark matter to interact with ordinary matter. Year after year they detect nothing. Particle colliders smash atoms at energies once thought unimaginable, searching for new particles that could explain the invisible majority of the universe. Yet the detectors remain silent. No candidate appears. No breakthrough arrives. It is as though the universe hides its secrets behind a curtain that refuses to lift. This silence forces a chilling possibility into focus. The physics of the universe may be far stranger than we ever imagined. Perhaps dark matter is not a particle at all but a field, a fluid, a new kind of structure. Perhaps dark energy is not energy but a manifestation of spacetime geometry. Perhaps the universe contains hidden dimensions, curled so tightly that only gravity can slip between them. Perhaps the cosmos is more like a hologram, with the laws of physics encoded on a distant boundary. The missing physics is not a failure of science, it is an invitation. A call to explore deeper, to question assumptions, to rebuild our understanding from the ground up. But it is also a source of unease. If 95% of the universe is invisible, untouchable, and unexplained, then humanity is navigating reality with only a sliver of the truth. As you drift through the cosmic dark, watching galaxies swirl and the universe expand around you, one thought lingers like a distant echo: the equations are incomplete. The universe is speaking in a language we do not yet understand. And the greatest secrets lie not in what we know, but in what remains hidden in the missing physics. There are moments when the universe feels too vast, too intricate, too finely balanced to be alone. Moments when the patterns woven through cosmic history seem to hint at something beyond this single reality. And it is here, in the deep silence between galaxies, that a bold idea takes shape: the possibility that our universe is only one of many, a shadow among countless shadows, a chapter in an infinite library of cosmic stories. This is the dark multiverse hypothesis, an idea as thrilling as it is terrifying, suggesting that what we call existence might be only a sliver of a greater, darker whole. Imagine rising above the cosmic web, drifting beyond clusters and superclusters, rising higher until the entire observable universe shrinks into a shimmering bubble suspended in darkness. That bubble is not solid. It quivers. It expands. It pulses with the energy of dark matter and dark energy pushing against it. Now imagine hundreds, thousands, millions of such bubbles floating nearby, some larger, some smaller, some older, some just beginning to form. They hover in a vast, unseen medium that may have no beginning or end. This is one vision of the multiverse, a cosmic sea where universes are born like droplets in a storm. But the dark multiverse is stranger still. It proposes that most of these universes might be invisible not because of distance, but because they are made from forms of matter and energy so unlike our own that light cannot cross the boundary. They could be composed of different particles, governed by different constants, shaped by different versions of physics. Some might be frozen, lifeless expanses of silence. Others might burn hotter and faster than ours, consuming themselves in cosmic firestorms. And some might be eerily similar, universes where galaxies form, stars ignite, and life might evolve along unfamiliar paths. Imagine drifting through this cosmic sea, approaching a universe whose fabric vibrates at a slightly different frequency. The boundary shimmers like the surface of a pond disturbed by a breeze. On the other side is darkness, deeper, heavier, more layered than anything within our cosmos. It is not empty. It is structured, full of patterns we cannot decipher. You sense shapes and motions behind the veil, but your eyes cannot interpret them. It is as if you are witnessing reality being written in an alien language. Some theories suggest that dark matter might be a clue, a hint that forces or particles from a neighboring universe bleed into ours. Perhaps it is not truly part of our cosmos. Perhaps it is gravitational leakage from another universe brushing against our own, its matter invisible but its gravity unmistakably real. If that is true, then dark matter is not simply a hidden force. It is evidence of another reality overlapping ours, like ghostly fingerprints pressed against the fabric of space. Imagine dark matter filaments stretching through our cosmos like tendrils from another dimension. They guide galaxies but they do not glow. They shape the universe but they do not interact with the particles we know. Perhaps they are made of matter that belongs to a neighboring universe, passing through ours as effortlessly as shadows slipping across a wall. If this idea is true, then the cosmic web is not just a structure within our universe, it is a bridge between realms. The dark multiverse hypothesis also raises the possibility that our universe might not be the original. Perhaps it is a descendant, a child spawned by the death of a previous universe. In some models, when a universe collapses under its own gravity or stretches beyond stability, it gives birth to new universes. Each inherits a set of physical laws, slightly altered by the conditions of its birth. Over countless cycles, the multiverse becomes a generational tree, a sprawling family of universes, each shaped by the successes and failures of its ancestors. Imagine standing in the ruins of a dying universe, where spacetime is collapsing inward, folding like burning paper. In the final moments of that cosmic death, a burst of energy erupts, an explosion not into space but into a new space entirely. That explosion becomes a new universe's Big Bang, complete with its own dark matter, its own dark energy, its own cosmic web. Our universe might be one such child, unaware of the countless generations that came before. But the most haunting idea is that universes might interact, not through light or matter but through gravity. Gravity is the one force that escapes the confinement of dimensions. It leaks. It spreads. It slips between boundaries. If multiple universes exist nearby in the higher dimensional space, their gravitational fields might overlap, influencing the formation of structures in each other's realms. Dark matter could be the shadow of another universe's gravity passing through ours. Dark energy could be the result of our universe being stretched by expansion in a neighboring realm. The multiverse could be a gravitational ecosystem, with universes tugging at one another like celestial creatures drifting in a cosmic ocean. Imagine drifting close to the boundary of our universe, sensing faint ripples, gravitational waves passing in from beyond. They distort space-time gently, subtly, too weak for early instruments to detect. But now, with sensitive detectors listening to the cosmos, we may be hearing the first whispers of other universes. The sounds are faint, but they exist, a cosmic hum with frequencies that hint at structures beyond our own. Some theories envision universes stacked like sheets of paper, thin, vibrating membranes in a higher dimensional space. These brains, as physicists call them, might occasionally collide. When they do, the energy released could ignite a new universe. If so, the multiverse is not just a sea of cosmic bubbles, it is a symphony of vibrating membranes, each playing its own version of reality. Our universe is simply one note in a greater cosmic chord. Imagine two such universes drifting closer over billions of years. Their gravitational fields begin to influence each other, distorting their shapes. When they finally collide, the impact releases unimaginable energy, a blast so powerful it births a new space-time, a newborn universe expanding outward like a ripple in a pond. That ripple could be us. In this scenario, our universe is the byproduct of a cosmic collision, its laws and constants shaped by the nature of the brains that collided. And then there is the most unsettling possibility of all, that dark matter and dark energy are not substances or forces, but interactions between universes. Invisible pressure from neighboring realms. Gravitational waves passing from one universe into another. Energies leaking across cosmic boundaries like heat passing between rooms. If true, then everything we think is wrong with our physics may not be wrong at all. It may simply be incomplete because we have only ever studied one universe in a multiverse of infinite complexity. Imagine the implications. The cosmic web might be shaped partly by structures in other universes. Dark matter halos might be filled with matter from beyond our realm. The accelerating expansion might be caused by the influence of neighboring universes pulling at ours, stretching it like taffy. Every galaxy, every star, every atom might be caught in a vast multidimensional tug-of-war. As you drift through this grand vision, surrounded by countless unseen universes, a profound realization settles over you. Our cosmos is not isolated. It is part of something immeasurably larger. Something deeper. Something older than our own Big Bang. The section ends with a lingering tension, a sense that the darkness surrounding us might not be empty but full. Full of neighboring realities brushing against ours. Full of answers. Full of unknown forms of existence waiting in the silent depths of the multiverse. And within that silence, one question echoes. If our universe is only one shadow among many, then what else is hiding in the darkness beyond our cosmic horizon? In the deep quiet of the cosmos, where even starlight grows thin and faint, there exists a kind of listening, a patient, desperate search for whispers hidden within the dark. Scientists scan the void not for what they can see, but for what refuses to be seen. They listen for echoes in the black, faint ripples and distortions that hint at phenomena more elusive than light itself. These echoes are not sounds. They are patterns, anomalies, tiny deviations in the fabric of reality that suggest something in the darkness is stirring. Imagine drifting inside a vast laboratory buried beneath a mountain, shielded from every stray particle of the outside world. The quiet is absolute, broken only by the soft hum of detectors waiting for a signal so rare that it might arrive only once in a decade. These machines watch for ghostly particles, dark matter candidates, that slip through Earth like phantoms. They are tuned to the slightest vibration, the faintest electrical pulse, the smallest tremor. Yet time passes and the detectors remain silent. It is a silence both peaceful and terrifying, a silence that suggests dark matter may interact even less than we feared, or that we are not listening correctly. Still, anomalies appear. Not often. Not loudly. But enough to raise eyebrows and ignite curiosity. A single unexpected pulse. A sudden fluctuation. a signal that cannot be explained by known particles. Most of them vanish under scrutiny, revealed as false alarms or statistical noise. Yet some linger, quiet, persistent, refusing to be dismissed. They are faint echoes from the black, teasing the edges of our understanding. Imagine a beam of particles streaming from the heart of a distant galaxy. These particles race across billions of light-years, unimpeded by gas or dust, passing through stars and planets as though they do not exist. Only the most sensitive detectors can hope to catch them, and even then they whisper their presence as barely measurable distortions. Their arrival raises unsettling questions. Are these particles ordinary, or are they hints of a hidden sector of the universe, made from matter and forces we have never observed? Scientists examining cosmic radiation sometimes find unusual patterns. Energies too high, directions too odd, distributions too uneven. These anomalies appear like fingerprints from the darkness, marks of interactions that should not occur. They suggest collisions between dark matter particles or decay processes that violate known physics. Each anomaly is a message without a sender, a riddle without a language. Imagine drifting through intergalactic space, where the cosmic microwave background stretches like a soft, ancient glow. Embedded in this glow are tiny temperature variations, the leftover whispers of the early universe. But when analyzed with increasing precision, scientists discover subtle irregularities, spots slightly warmer, slightly colder than predicted. These deviations are faint, barely detectable, yet they hint at forces or particles that rippled through the early cosmos. Perhaps dark matter left behind these imperfections as it clustered into the first filaments. Or perhaps something else, something stranger, left its mark before the universe cooled. Then there are the gravitational waves, ripples in spacetime produced by dramatic cosmic events. Most come from black hole mergers or neutron-star collisions, their signatures clear and unmistakable. But occasionally detectors pick up faint signals that do not match any known pattern. They are too slow, too smooth, too drawn out. Some scientists speculate they might be caused by dark matter structures drifting through space. Others imagine them as echoes from hidden dimensions or exotic cosmic strings vibrating in the void. Whatever their origin, these waves carry a strange music, an ancient rhythm echoing through the dark. Imagine a network of telescopes on Earth and in orbit, all tuned to monitor distant galaxies. Over time, astronomers notice strange distortions in starlight, slight bends that cannot be explained by visible mass alone. These distortions are gravitational lensing, light bent by dark matter. But the patterns are uneven, shifting in ways that suggest the presence of clumps or waves of unseen mass. It is as if something in the dark is moving, reacting, or communicating through gravitational signals alone. In some regions, galaxies flicker faintly, their brightness varying without clear cause. Some attribute this to dark matter interactions that subtly alter their light. Others suggest more exotic possibilities, unknown particles streaming through the galaxy, scattering photons in ways too rare to observe directly. These faint flickers are like cosmic Morse code, messages transmitted in a language we have not yet deciphered. Imagine drifting inside a deep space probe traveling far beyond the edge of the solar system. Its instruments detect slight anomalies, tiny changes in trajectory, minute variations in the background particle flux. At first, these anomalies seem random. But over time, patterns emerge. They hint at currents of dark matter flowing through the region, or perhaps at structures made from unknown particles. These subtle signals, though barely measurable, could be the first direct evidence that the darkness is not static, but alive with motion. Some scientists envision even more profound possibilities. What if dark matter occasionally decays, releasing particles that standard detectors can catch only indirectly? What if dark matter interacts with itself, creating faint bursts of energy deep in the void? These bursts would be invisible to telescopes, but they might leave gravitational echoes, ripples that spread across the cosmos. Such events would be like distant thunder in a storm we cannot see. Imagine standing on a distant world in a galaxy billions of years from now. The night sky stretches above you, filled with stars dimmer than they once were. But here and there, faint distortions ripple across the darkness. These are echoes from the black, quiet reminders that the universe is full of unseen forces shifting behind the curtain of reality. Each anomaly, each whisper, each unexplained distortion is a clue, a sign, a subtle tap on the shoulder from the unseen realm. Something in the darkness is interacting, behaving, responding in ways we do not yet understand. There are theories that spark curiosity, theories that challenge imagination, and then there are theories that awaken something deeper, an ancient instinct buried within the human mind. A stirring of fear, a whisper of danger. Among all the speculative frontiers of cosmology, none is as unsettling as the idea that the universe might contain entities, forces, or structures capable of consuming or manipulating cosmic regions on unimaginable scales. This is the cosmic predator theory, the notion that the darkness might not merely be a passive backdrop, but a hunting ground. Imagine drifting through a quiet region of the universe, far from the safety of any galaxy. The darkness seems gentle, serene, almost comforting. But then you notice something strange, an absence where stars should be. Not just a void, not just a gap. A region where light seems to be swallowed rather than dimmed. The boundaries of the area ripple faintly, as though space itself is being disturbed. You feel an instinctive tension, the same instinct that once warned your ancestors of unseen predators lurking beyond the firelight. Something is wrong here. In the known universe, gravity shapes everything. Yet certain cosmic anomalies defy the expected behavior of gravitational collapse. Entire star clusters vanish from observation, not over billions of years, but over surprisingly short cosmic timescales. Regions of space that should be stable appear disturbed, warped, as if influenced by forces far stronger than anything we understand. These unexplained disappearances have led some astrophysicists to propose radical ideas, that unknown forms of matter or energy, far more aggressive than dark matter, might be interacting with the universe in predatory ways. Imagine a massive structure drifting silently through space, dark, undetectable, leaving behind only gravitational scars. It has no glow, no temperature, no reflection. It interacts with normal matter only through gravity, yet its influence is profound. As it passes near a star cluster, the stars begin to wobble, their orbits stretched into unnatural shapes. The cluster starts to thin out as if something invisible is siphoning away mass. No collision. No explosion. No radiation. Just disappearance. Such an entity would not resemble anything in known physics. It would be a gravitational predator, an eater of structures, a cosmic phantom feeding on the architecture of galaxies. And then there are the black holes, cosmic monsters that devour everything in their reach. But what if black holes themselves are only the smallest members of a larger family of predatory forces? What if there exist objects with gravitational influence so diffuse and large that they do not swallow stars outright, but quietly pull them apart from a distance? These hypothetical entities, stretching across thousands or even millions of light-years, would be invisible to any telescope. They would move through the universe like drifting shadows, consuming energy and matter with terrifying patience. Imagine a filament of dark matter suddenly thickening, becoming denser, more aggressive. It begins to pull galaxies toward it, one by one. These galaxies stretch, distort, and then fade as they fall into the filament's gravitational maw. The filament brightens slightly, not with light but with gravitational influence. It grows in strength as it consumes. If such behavior were possible, the cosmic web itself could act as a hunter, feeding on galaxy clusters, reshaping the universe with predatory intent. Some theoretical physicists have proposed even stranger possibilities, that the universe might contain fields or particles capable of altering matter at a quantum level, dissolving it, converting it into forms undetectable to our instruments. If such fields drifted through space, they could erase entire regions of matter invisibly. A galaxy could vanish without a trace, leaving only gravitational ripples as evidence of its former existence. These hypothetical phenomena are sometimes called cosmic dissolvers, and although they remain purely speculative, they haunt the edges of scientific thought. Imagine encountering a region where atoms themselves begin to fail, where the forces that bind them weaken inexplicably. Stars dim, planets crumble into dust, and the dust itself dissolves into nothing. There is no explosion, no radiation, no warning. Only a silent unraveling. This would be the ultimate predator, a force that does not consume matter violently, but unravels the very laws that hold it together. There is another possibility, one even more unsettling. What if some predatory cosmic phenomena are not destructive but manipulative? What if they alter the flow of dark matter or dark energy, using these unseen forces to reshape regions of space? If intelligence exists in forms beyond matter, it might not need technology or machinery. It might manipulate the universe through the invisible scaffolding of dark matter itself, bending galaxies to its will like a puppeteer pulling unseen strings. Imagine drifting into a galaxy where the spiral arms appear twisted unnaturally, where star formation follows patterns too deliberate to be random. It is not a mechanical structure, not a Dyson sphere or artificial shell. It is the galaxy itself, sculpted into a tool, a habitat, or a weapon by something that understands dark matter better than any human scientist. This is not a predator in the biological sense, but a cosmic architect capable of repurposing galaxies like clay. Some researchers studying unusual galaxy alignments have found patterns that defy statistical explanation, subtle but persistent indicators that galaxies over enormous distances seem to orient themselves in improbable ways. Could these be signs of an unseen influence? A manipulation from the deep dark? It is a question that unsettles even the boldest cosmologists. Imagine drifting through a region where the cosmic background radiation appears warped, twisted in a pattern that resembles a signature, a calling card, or a territorial boundary. If a civilization evolved using dark matter or dark energy as tools, their presence might be utterly invisible to us, except for gravitational fingerprints left behind in cosmic structures. These fingerprints could be misinterpreted as natural anomalies, or they could be warnings. And then there is the darkest idea of all, that something in the universe is actively consuming not matter but space itself. A vacuum instability, a runaway region where the fabric of reality collapses into a lower energy state. Such an event would spread at near light speed, destroying everything in its path. Invisible, unstoppable, silent. Not a creature. Not a consciousness. But a cosmic predator in the purest sense. A force of annihilation moving through the universe like an expanding black tide. If such a phenomenon existed, we would never see it coming. As you drift deeper into the cosmic night, the idea grows heavier. The universe may not be a peaceful garden of stars, but a wild cosmic wilderness filled with predators we cannot see. Dark matter currents. Exotic fields. Reality-eating instabilities. Entities made of unknown particles. Structures shaped by forces older than galaxies. There comes a moment when even the bravest stars must confront the truth. They are losing a war they never chose. For billions of years, light has battled the darkness, pushing back against the void with every flare of fusion, every explosion of brilliance, every birth of a new sun. But now the balance of power has shifted. The universe is expanding faster than these ancient fires can compensate, stretching space so quickly that even the most powerful galaxies can no longer hold themselves together. This is light's last stand, not dramatic, not explosive, but painfully slow, a quiet surrender unfolding over trillions of years. Imagine drifting inside a rich galaxy cluster, watching thousands of galaxies swirl like a storm of luminous islands. Their collective glow illuminates the dark matter halo holding them together. But something feels different, subtle at first like a faint tension in the air. The edges of the cluster begin to fray, the outer galaxies drifting away as though tugged by an unseen current. They stretch like grains of sand being pulled from a shoreline, disappearing into the accelerating darkness. The cluster is not changing because of internal forces. It is being stretched by the universe itself, its luminous heart slowly unraveling. In this growing shift, stars fight desperately to preserve their domains. They burn their nuclear fuel with fierce determination, flinging light into a cosmos that no longer listens. Even the brightest supergiants, vast enough to engulf entire solar systems, find their influence reduced to a pale whisper. Their glow, once a beacon across cosmic distances, now fades more quickly as space lengthens the wavelengths of their photons, turning bright blue fire into faint red embers. Imagine a lone star on the outskirts of a galaxy, shining defiantly against the encroaching dark. Its light travels outward, carrying warmth and information, crossing trillions of kilometers. But the space between the star and its observers stretches faster than the light can conquer. By the time its photons arrive, they are weakened, spread thin, transformed into cold whispers of infrared radiation. The star's presence becomes a ghostly flicker, real but doomed to fade. Galaxies themselves begin to feel the strain. Their outer arms loosen, pulled gently but inexorably toward the expanding night. Gas clouds drift too far from star-forming regions to ignite new suns. Star nurseries grow quiet. Nebulae go dark. The spiral arms of great galaxies slowly unwind, like ancient tapestries unraveling thread by thread. The grand designs that once decorated the cosmos with grace become distorted silhouettes barely clinging to coherence. Imagine watching the Milky Way from a distant vantage point deep in the future. The brilliant arms full of young stars are gone. The galaxy has become faint, dim, its edges torn away. The once vibrant stellar nurseries have fallen silent. Only the red dwarfs, small, stubborn, and slow-burning, continue to glow faintly, defying extinction with their remarkable longevity. But even their light is stretched and weakened by the expanding void, becoming faint signals swallowed by the cosmic ocean. As space grows, light's reach shrinks. Photons that once traveled effortlessly across vast expanses now struggle to carry their energy. They arrive as stretched shadows of their former selves. The beautiful colors of nebulae, reds, blues, greens, drain into infrared, then microwave, then silence. The universe becomes a darker place, not through violence but through the slow erosion of every luminous effort. Imagine a time far beyond the age of galaxies, when only a handful of stars remain. They drift alone, isolated by distances so immense that communication between them becomes impossible. Their light travels outward but never reaches another observer. The expansion of space outpaces their photons completely. To these last suns, the universe is not a cathedral of galaxies. It is a personal void, a prison of infinite solitude where each star shines only for itself. The decay continues. Even the most durable stars eventually exhaust their fuel. Red dwarfs flicker out after trillions of years, leaving behind cold, dead remnants. Black dwarfs, silent spheres of carbon and oxygen. These failed stars drift like cosmic ashes, carrying memories of brilliance long past. They do not glow. They do not warm. They do not resist. The darkness accepts them without objection. Imagine drifting among billions of such remnants, each one a tombstone marking the death of a star. They float through a universe so stretched that galaxies no longer exist. Light itself has become rare. The cosmic microwave background has cooled to nearly nothing. Dark energy has pushed every surviving particle impossibly far from every other. The universe, once filled with blazing stars and swirling patterns, has become a sparse desert of cold, isolated objects drifting through an unending night. Black holes remain, the final collectors of the universe's luminous past. They devour the remnants of stars, swallowing them in silent collapses. Yet even they cannot escape the encroaching emptiness. Over unimaginable spans of time, black holes evaporate through Hawking radiation, fading into darkness. Their last moments produce a faint burst of energy, a final spark of light released into a universe too large to notice. Imagine witnessing the evaporation of the last black hole in existence. A tiny flash, a whisper of energy, a final protest against oblivion. And then it too is gone. The universe is now a vast, cold expanse where light has made its last stand. No stars remain. No galaxies. No warm glow to soften the edges of the infinite. Only particles drifting endlessly, separated by distances so great that they may as well exist in different realities. And yet, even in this ultimate night, there lingers a haunting beauty. Light did not lose because it was weak. It fought against expansion, against entropy, against the collapse of stars and the death of galaxies. For billions of years, it carved meaning into the void, illuminating the cosmos with stories of creation and destruction. Its legacy remains in every surviving particle, in every stretched photon fading into the deep dark. Light's last stand is not a defeat, it is a final reminder of the brilliance that once defined the universe. But now the darkness rules. There is a moment, somewhere in the immeasurable future, when the universe pauses, not in time but in meaning. A moment when everything that has ever existed converges into a single haunting question. What will become of the cosmos when darkness finally wins? The answer is not singular. It is a sprawling landscape of possibilities, each one shaped by the unseen forces that govern the expanding night. To explore the fate of the dark universe is to drift into a realm where physics meets prophecy, where calculations become myths, and where every outcome carries the weight of eternity. Imagine standing in the silent depths of intergalactic space, far from any star, far from any warmth. All around you stretches a cold ocean of darkness, disturbed only by the soft gleam of distant galaxies drifting away faster than light can chase. Their motion is relentless, driven by the accelerating expansion of dark energy. As centuries turn into millennia, millennia into millions of years, the expansion grows stronger, pulling the cosmic web apart strand by strand. Galaxies become isolated. Clusters lose their connections. The universe fractures into countless island universes drifting through an ever-deepening night. This is the first possible fate, eternal expansion. A universe that continues to stretch until all structure becomes impossible. Imagine watching a galaxy from afar, its graceful spiral arms shimmering like cosmic wings. Over time, the galaxy begins to thin, not because of internal chaos, but because the space around it is expanding. Stars drift farther apart. Gas clouds can no longer gather to form new suns. Star formation slows, then stops entirely. The galaxy ages, its brilliance fading as its final generations of stars burn out. Eventually, only long-lived red dwarfs remain, tiny points of stubborn light scattered across an enormous void. They glow quietly for trillions of years, resisting the inevitable. But even they cannot escape the cold logic of eternity. One by one the red dwarfs flicker out, leaving behind black dwarfs, dead stars, frozen and silent. Planets become icy tombs. Entire solar systems collapse into stillness. In this version of the future, the universe becomes a graveyard of extinguished stars drifting through an infinite darkness. But there is a second fate, more dramatic and more terrifying, the Big Rip. In this frightening scenario, dark energy does not remain steady. It grows. It accelerates unchecked. It becomes a cosmic pressure that stretches space faster and faster, like a drum skin pulled until it tears. Galaxies would not merely drift apart, they would be ripped apart. Stars would be torn from galaxies. Planets would be torn from stars. Eventually, even atoms themselves would unravel, the electromagnetic force unable to resist the expansion of space. Imagine watching two planets orbiting a star. Their paths are stable, predictable, serene. But the expansion intensifies. Slowly their orbits loosen. They drift outward. The star tries to hold them, but gravity becomes weaker relative to the stretching of space. Eventually the planets break free. Then the star itself begins to deform. Its layers separate, pulled apart in a slow-motion catastrophe. Light streams into the void as the cosmic tear widens. In the final moments, even the particles that compose matter are pulled apart, leaving behind a universe not merely dark but featureless. An empty space with no structure, no particles, no time as we know it. And then there is a third possibility older than the stars and far more poetic. The Big Crunch. In this scenario, dark energy might weaken or reverse. The expansion could slow then halt. Gravity, patient and persistent, could reclaim control over the cosmos. Galaxies would begin drifting toward each other again. Clusters would merge. The cosmic web would tighten. The universe would contract. Imagine galaxies colliding not because they fall into each other's arms naturally, but because the entire cosmos is collapsing inward. The night sky grows brighter as distant galaxies come closer. The universe becomes a dazzling inferno of merging structures. Black holes multiply, devouring stars and entire systems. Their gravitational fields stretch across the collapsing cosmos. Eventually, the universe condenses into a brilliant, violent core, a final singularity where everything is crushed into a measurable density. From this singularity, perhaps a new universe might be born, its Big Bang the echo of a cosmic death. But the fate of the dark universe may be even stranger than these possibilities. Some theories suggest a cyclical cosmos, one where the universe expands, collapses, and is reborn endlessly. In this view, dark matter and dark energy are not just properties of our universe but ingredients in a cosmic rhythm that plays out eternally. Imagine a universe dying and being reborn in a loop, each cycle imprinting subtle changes in the next. In one cycle, galaxies form earlier. In another, dark matter behaves differently. In another, physics itself shifts, giving rise to new patterns of cosmic evolution. The universe becomes a cosmic heartbeat. Expansion, collapse, rebirth, repeat. Its rhythm measured not in billions of years but in quadrillions. Another theory proposes that the cosmos will dissolve into a state of quantum foam, a realm where the orderly structure of spacetime breaks down entirely. In this scenario, the universe does not collapse or rip apart. It simply cools into a profound, delicate stillness, where space and time fluctuate like tiny waves on an invisible sea. No stars. No galaxies. No matter. Only the whisper of quantum uncertainty, flickering in and out of existence. Imagine drifting through this final state. There is no sense of direction, no sense of scale. Reality becomes a shimmering haze of probabilities. Particles appear and vanish. Space flickers. Time loses meaning. The universe is not dead but transformed, reduced to its most fundamental essence, a canvas of pure potential waiting for conditions that might ignite it again. Some theories even suggest that this quantum foam could spawn new universes in a branching multiversal tree. If so, then the fate of our universe is not an ending but a transformation, a transition from one cosmic identity to another. But there is one more possibility, one that is both hopeful and unsettling. Perhaps the universe will not end in collapse, expansion, or dissolution. Perhaps it will evolve into something entirely new. Perhaps dark matter will change. Perhaps dark energy will shift. Perhaps unknown forces will emerge, guiding the cosmos into a phase we cannot yet comprehend. Imagine a distant future in which the universe becomes a realm dominated by exotic particles, new forms of structure, or even consciousness woven from the fabric of space-time itself. Perhaps intelligence will adapt to the darkness, surviving long after stars have faded. Perhaps the universe will not die, only change hands, shifting into a state where new forms of existence thrive in ways we cannot imagine. As you drift through these possibilities, one truth becomes clear. The universe is not a static story. It is a living, evolving mystery, shaped by invisible forces that guide its destiny. Whether it ends in flame, frost, silence, or rebirth, its final chapter will be written not by light, but by the dark forces that have ruled since the beginning. And as the last galaxies fade from sight, one haunting question remains suspended in the cosmic night. Is the universe moving toward an ending, or toward something far more extraordinary than anything we have ever seen? Humanity's search for the invisible did not begin with telescopes, equations, or laboratories buried beneath mountains. It began long before science had a name, when the first humans looked up at the night sky and felt something stir inside them. A mix of wonder, fear, and longing. The recognition that the darkness above was not merely a roof of stars but a gateway to something larger. Something hidden. Something waiting to be understood. Since that moment, our species has been driven by a primal curiosity, a desire to uncover what lies beyond the limits of sight. Imagine one of those early humans standing near a fire, staring into a sky unpolluted by light. The Milky Way stretches overhead like a celestial river, rich with secrets. The darkness between the stars feels alive as though watching. In that moment, the human mind begins to ask questions for the first time. What are those lights? Why do they move? What lies beyond them? Without instruments or knowledge, these early thinkers were already reaching into the invisible, forming stories, myths, and philosophies in an attempt to grasp something so vast it defied description. As civilizations rose, this curiosity deepened. Ancient astronomers charted the heavens with painstaking detail, noticing patterns that repeated, stars that wandered, shadows that foretold eclipses. They built monuments aligned with celestial movements, embedding their understanding of the cosmos into stone. They believed the heavens were alive with gods or spirits, not because they were wrong, but because they sensed an order too grand to be mere coincidence. They were reaching, grasping, pulling at the edges of the unknown. Centuries later, the world changed. The invention of the telescope allowed humanity to pierce the veil for the first time. Suddenly, the moon revealed mountains and craters. Jupiter showed swirling storms and moons of its own. Saturn displayed rings like halos. The darkness between stars grew smaller, filled with new wonders. Yet the more we saw, the more we realized how much remained invisible. For every discovery made with light, a deeper shadow appeared behind it, hinting at mysteries not revealed by illumination. Imagine Galileo lifting his telescope toward the heavens for the first time, unaware that he was beginning a chain of discoveries that would eventually challenge the very structure of the universe. His observations did not merely add details, they shifted the human perspective, making the cosmos larger and more complex. But even then, the stars were only a fraction of the truth. As technology advanced, scientists discovered that visible light was just a tiny slice of the electromagnetic spectrum. Radio waves, infrared radiation, ultraviolet light, X-rays. Each window revealed new features of the universe. Nebulae glowed with hidden heat. Black holes distorted space around them. Pulsars flickered like cosmic clocks. But behind all of this new knowledge lay something stubbornly untouched by every wavelength. The dark. Imagine a modern astronomer staring at an image from the Hubble Space Telescope. Thousands of galaxies fill the frame, each one a universe of stars. Yet something feels incomplete. The motions of those galaxies do not match their visible mass. The light is lying. Or rather, it is telling only part of the story. The invisible begins to take shape, not as myth but as data. Dark matter. Dark energy. The unseen foundations of reality. Humanity's journey to understand the invisible becomes a scientific pilgrimage. Researchers build detectors deep underground, shielded from radiation and cosmic rays, hoping to catch a single particle of dark matter. They construct enormous telescopes in deserts and mountaintops, searching for distortions in starlight that signal hidden mass. They launch satellites into orbit to measure the cosmic microwave background, the faint afterglow of the Big Bang, looking for clues about the universe's earliest moments. Imagine a physicist sitting alone in the dim glow of a computer screen, analyzing data from an experiment that took years to build. They scroll through numbers looking for anomalies, tiny deviations that might signal the presence of an unknown particle. Months pass. Dead ends. False signals. Silence. But the scientist continues, driven not by certainty but by hope. Hope that one day the invisible will answer back. Humanity's search expands beyond matter and energy. Philosophers and cosmologists begin asking deeper questions. What is the nature of space itself? What is time? Are these fabric-like structures or emergent phenomena? Are we living inside a universe with hidden dimensions curled beyond our perception? Could other universes exist alongside ours, influencing us only through gravity or exotic interactions? The invisible becomes not just a physical frontier, but a conceptual one. Imagine standing in a research center where scientists debate the nature of reality. One argues that dark energy is a property of the vacuum. Another claims it's a field permeating space. A third suggests it could be the influence of neighboring universes. Their disagreements are not failures. They are signs of how young humanity still is in its understanding. The Cosmos is a book with most of its chapters unread, its language only partly deciphered. Yet the search does not belong to scientists alone. Every person who has ever stared into the night sky and felt a spark of wonder participates in this pursuit. Every child who imagines life on distant planets. Every poet who describes stars as ancient eyes. Every philosopher who questions the origin of existence. This shared curiosity is one of the few instincts woven into every culture across time. Imagine a young student looking at a star map projected onto a classroom wall, realizing for the first time that each dot represents a place, a potential home, a mystery, a beacon. That moment may be small, but it is part of the same thread that began with ancient stargazers. Humanity's search for the invisible is not about answers. It is about the longing to know, the drive to push beyond the boundary of light. And through it all, one truth remains: the invisible is not the enemy of knowledge. It is the fuel of discovery. It is the reminder that the universe is more than what our senses can perceive. It is the frontier that keeps expanding, calling us forward. As you drift through the silence of intergalactic space, one thought echoes: humanity is small, but its curiosity is vast. And as long as that curiosity endures, the journey toward understanding the invisible will never end. There comes a moment in the vast timeline of the cosmos when humanity must confront a truth both terrifying and transcendent. We are not separate from the darkness, we are moving toward it. The universe is not guiding us back toward the light that birthed us, but into a realm where luminosity becomes rare, then fragile, then meaningless. What began as fear of the night sky may one day become an invitation to evolve. For in a universe ruled by shadow, survival may demand something unimaginable: that humanity changes, adapts, and perhaps becomes part of the darkness itself. Imagine a far future civilization standing beneath a sky almost emptied of stars. The Milky Way has long since merged and dissolved into a faint smear of ancient remnants. The night is no longer dotted with brilliant constellations but filled instead with an overwhelming, endless black. To these distant descendants, this darkness is not frightening, it is normal. It is the environment they have inherited. It is the canvas on which their existence now depends. Their bodies, their senses, their very biology have transformed to survive in this dimming cosmos. Eyes evolve to detect faint infrared whispers instead of visible light. Brains adapt to process gravitational signals, learning to sense the distortion of space itself the way ancient humans sensed sound or heat. Light was once our guide. Now, gravity becomes our language, and darkness becomes our home. Imagine drifting through an artificial habitat orbiting a dying star. Inside, humans, if they can still be called that, navigate using senses unfamiliar to present-day minds. They feel the shape of nearby objects as subtle tugs on their perception. They move through corridors guided not by illumination but by the curvature of spacetime their minds can now detect. Light is no longer required. The absence of it is no longer feared. Instead, darkness is a medium, soft, comfortable, intimate. As stars fade and galaxies disappear beyond the reach of light, humanity's descendants begin to harness forces that once seemed impossible. They learn to manipulate dark matter, not completely but enough to use its gravitational currents for travel. They drift along invisible rivers of unseen mass, sailing through the universe like ancient mariners following ocean tides. Each journey is silent. Each route carved not by engines but by gravitational resonance. Imagine a vessel made not of metal but of exotic materials that resonate with the hidden structure of the cosmos. It glides effortlessly using dark matter streams as highways. Its passengers are calm, patient beings accustomed to navigating a universe without visual cues. Their understanding of reality is shaped not by sight but by subtle gravitational waves, flickers of quantum fields, and faint signals that lie far beyond the reach of ancient human senses. Civilizations evolve around black dwarfs and slowly cooling neutron stars. These embers of stellar glory become havens of warmth in an otherwise frozen infinity. Communities form in the quiet glow of long-dead suns, surrounded by artificial energy fields that stretch and distort in the dark. Life clings to the last sources of heat, adapting, thriving, refusing to surrender to entropy. But even black dwarfs eventually fade. Neutron stars cool. Black holes evaporate. The universe grows colder still. At this stage, humanity's descendants face a choice: perish with the dying light or transform into something entirely new. Imagine consciousness moving beyond biology. The last remaining beings upload their minds into structures encoded within the quantum vacuum itself. They take refuge in the fabric of space-time, existing as patterns of information that can survive the cold. No heat is needed. No stars. No matter. They become entities woven from the same silent forces that bind the universe. Their thoughts ripple through the dark like soft waves, shared across unimaginable distances through subtle gravitational vibrations. These beings no longer fear darkness because they are made of it. They inhabit it. They understand it intimately. They drift through the silent universe not as fragile creatures of carbon and water, but as immortal patterns, echoes of humanity encoded in the gravitational fields that surround them. Imagine a future where the universe has grown so vast and cold that nothing moves, nothing changes, nothing shines. And yet, faint ripples still travel through the darkness, ripples that carry memory, consciousness, identity. These ripples are the final evolution of humanity, beings of pure information, carved into the geometry of the cosmos itself. In this final era, darkness is no longer the enemy. It is the cradle. It is the medium through which existence continues. Light was a chapter, brief, brilliant, but temporary. Darkness is the rest of the book. As you drift deeper into this vision, a profound realization settles over you. The universe may grow cold. Stars may fade. Galaxies may disappear. But life, adaptable, curious, relentless, will not simply vanish. It will change. It will become something new, something capable of thriving in the quiet where light once shone. Humanity's story does not end when the stars go dark. It evolves into a final form, one that embraces the darkness not as a threat but as a destiny. For in the deepest future, when matter itself is sparse and the universe whispers its last faint breath, humanity may not just survive the darkness. Humanity may become the darkness. At the edge of the universe's final silence, when the last traces of starlight have stretched beyond recognition and the cosmos itself has thinned into a cold, trembling fabric, a final question rises from the dark. It does not burst forth like creation's first fire, nor whisper like dying starlight. It simply exists, quiet, ancient, patient. A question waiting for someone to hear it. Imagine drifting alone in this distant era, where galaxies no longer glow and the cosmic web has unraveled into faint gravitational ghosts. The darkness feels infinite, untouched, an ocean without surface or depth. Yet in this stillness, you sense the faint echo of everything that came before, vibrations left behind by stars collapsing, galaxies colliding, civilizations rising and falling across billions of years. These ripples are memories etched into space-time itself. You listen, and the universe speaks not with words but with its absence. Its silence becomes a mirror reflecting the grand arc of existence. The birth of matter, the rise of life, the flowering of intelligence, the final dimming of light. All of it contained within this quiet, suspended moment. And then the question reveals itself. Was the universe meant to be understood? Or was the search for meaning simply a spark inside consciousness, a flame that burned brightly even as the cosmos drifted toward darkness? Perhaps the end is not an ending at all. Perhaps the fading of one universe becomes the seed of another. Quantum fluctuations stir in the deep dark, tiny tremors hinting at future worlds, future laws, future light. Or perhaps the ultimate purpose was never about survival, but about witnessing the mystery itself. As everything grows silent, one truth remains. The universe does not close its story with certainty, but with possibility. The final question lingers, unanswered, eternal, waiting in the dark.